Hello everyone. Let us quickly summarize what we have covered so far. In the previous lecture, we had defined cloud computing, or at least we tried to define cloud computing because we couldn't really nail a definition to what cloud computing is, because it means different things to different people, and sometimes how they see the cloud computing, how they see the cloud, depends on what they use it for. We also spoke a bit about service-oriented architectures and service level agreements. Then we moved on to discussing the characteristics of cloud computing. Now, in that context, we discussed on-demand self-service, where a consumer can unilaterally provision cloud capabilities. So what that means is a user could potentially subscribe to what is a resource. It could be a slice of time, a slice of server time, network storage, or anything else really. And this can be done automatically without requiring human interaction or with the interaction of the service provider. We then went on to discuss broad network access, where we reiterated the fact that the user only needs a good internet connection. That's all he needs, a good internet connection to access the cloud. Then there was resource pooling, where the resources of the cloud are pooled to serve multiple consumers in a multi-tenant model. And of course, as you know, there is location independence, and the consumer doesn't generally he doesn't have any knowledge of the exact location of the resources. He might have some vague idea of the overall geographical location of the resource, but it's not precise. So yeah, pretty much any resource could be pooled, including memory, network bandwidth, etc., etc. The different physical and virtual resources are dynamically assigned and reassigned. That's what you got to understand. So it's dynamically assigned and reassigned as and when needed, depending on what the consumer wants. We also looked into the problem of resources provisioning. There are two problems, if you can remember that. So one is underestimation and other one is overestimation. So the underestimation, overestimation of resources is, in a nutshell, it's very difficult to keep playing catch up with our computing requirements. And towards the end of the last week's lecture, we also looked at what rapid elasticity is and what is also measured service. Rapid elasticity is about the capabilities that can be provisioned and released rapidly to commensurate with the demand. Finally, we also looked at measured service, because again, don't forget, it's all about the pay-as-you-go model. Pretty much everything you subscribe can be metered at some level of abstraction, and also which is appropriate to the type of service being used. So then, the attributes or the characteristics we explained earlier describe the different ways that providers can offer their services to their clients. I think let's go back to what I said a couple of weeks ago. Now, one size doesn't fit all. I mean, there are different types of the different ways you can provision services on the cloud, and the different people need different things. So there are different models which cater to an audience, depending on whether you are just a mere user or whether you are a software engineer or whether you want the control of the entire architecture. So all of this is dependent on what the profile of the user is. Because this is a pay-as-you-go model, the IT resources are offered as a service that you basically rent. as opposed to purchasing it. So you don't purchase any resource, you basically rent it out. Therefore, there are different ways to provision these resources, and that's what these three things are. That's a few others which are a spin-off from these, but for the time being, we'll just discuss infrastructure as a service, platform as a service, and software as a service. And as we will look into greater detail as we go on. Now then, so software as a service is where a provider offers an application, something like, you guys are used to this. So if you're just merely using something like Office 365, that is a very good example of software as a service. So you just merely use the application or merely use the software, and you don't have control over anything else. Yeah, so that's software as a service. So where a client connects over the network to a cloud provider and they access the software. Infrastructure as a service is where the provider provides processing, storage, and other computing resources, and with that they can further develop whatever they want. And platform as a service is where the provider provides the ability to run applications. It provides the users the ability to run applications that they have created themselves. So yes, so platform as a service is where the cloud provider provides the user the ability to run applications that they have created themselves. Now, I completely appreciate that all of this wouldn't make much sense if we don't give examples. So we will try to make things easier for you to understand by giving some analogies, and hopefully it will help you contextualize these concepts better. So there you go. That's the agenda for today's for this lecture. So it is to discuss the 3 points on your screen. We look at the service models, the deployment models, and cloud economics. I think we have covered quite a bit of cloud economics over the past few weeks, and it kind of justifies why any business must embrace cloud computing. So we go a bit more deeper into this, or rather we kind of reiterate what we have said in the previous lectures as well, and we try to justify from why from the business point of view then they need to deploy cloud-based IT systems rather than go back to traditional on-site data centers. So we look at all of that. So yes, so the 3 things you see there are infrastructure as a service, platform as a service, and software as a service. So we kind of already know the brief meaning of each of these three things, but let's discuss it further. Let's start with looking at infrastructure as a service. With infrastructure as a service, the user is able to rent out or subscribe to the resources that enables them to run their own applications. So I'll say that again. So it helps them, it provides them the resources to help them run their own applications. So the user only subscribes to the infrastructure, but he will have full control over his application and the operating system. That's what you got. So each of these models depends, offer varying levels of control to the user. With infrastructure as a service, in the process of developing an application, the client has got control over his application and operating system. The client also has control over their data and some limited network functionality and security as well. So what they could potentially do is they will be able to do things like configuring firewalls and other settings within the operating system. So all of that is possible with infrastructure as a service. So you can see how a small company might reduce a lot of their upfront cost, which is tremendous. Depending on the size of the company, the cost varies obviously, and it can be quite significant. But using infrastructure as a service, they can reduce a lot of their upfront cost because they don't have to incur the overwhelming task of provisioning expensive resources, because the resources are there on the cloud. You just subscribe to it. It also gives them the flexibility to use multiple operating systems. But like all these things, I think I mentioned last week or the week before that the debate about concerns about things like security, right, will always be there. So what are the security implications of infrastructure service, or what happens to all the shared resources? So these are some of that's an ongoing debate, and of course there are plenty of solutions for security and managing shared resources. Um, yeah, so but apart from that, it offers a lot of flexibility. So there are some pros and cons of the different approaches, and like I said, the solutions to all of that. But at the moment, let's not bother ourselves with all of that. So we'll probably get to discuss security at a different time as a part of a different discussion. So we'll leave it for the time being. Now, next thing you see there is platform as a service. Here, the client is provided with the entire computing platform required to develop and execute their applications. So like I told you in the very first lecture, the user has to tell the cloud provider what he wants to use, or rather what development platform they want to use. Is it C Sharp? Is it .NET? Is it Java? Whatever they need to tell the cloud provider. So the platform, that development platform, is provided by the cloud provider, and that way the developer himself doesn't have to maintain a dedicated IT team. He doesn't have to maintain an IT team of its own, because all the support is given at the back end by the cloud. So this eliminates having a dedicated IT support team, and also it also provides a very feasible approach in terms of portability as well. So it's a very cost-effective approach if a developer wants to develop a multi-platform application. So in terms of developing applications, you can develop an application on one platform and then use the cloud service to port that application to a different platform without stressing too much about what resources he needs. So it's like you just tell the cloud provider what you need, and they provide it to you, and then you just port the applications. So yeah, they can directly, so developers can directly rely on cloud provider to provide that cross-platform support as well. And finally, you have the software as a service, SaaS. And I think I mentioned this in the first lecture. This is the one thing which comes to mind pretty much straight away. So when people talk about cloud computing, the immediate examples which pop to mind is software as a service, because people connect to a lot of these applications on the cloud, and they think that's what software as a service is. In software as a service, the cloud hosts a range of applications, and the users can select which of those applications they want to use. But the good thing about this is they don't need to install their own applications. It's already made available to them. It's already there. So the way it works is the applications are hosted across multiple data centers, and typically the user's data is also stored there. Things like using Office 365. So you are very familiar in using Office 365. It's a classic example of software as a service. So you use you type in Word, you type a document in Word 365. And then you save the document probably on OneDrive or wherever. So it's all heavily cloud-based. So your application is hosted on the cloud, and your data is also stored on the cloud. So all of that is possible with software as a service. So all the user needs is what we call as a thin client. I mentioned the phrase or rather the term thin client in the very first lecture. So the thin client could be a web browser or a lightweight process that's running at the client's end. The thin client only requires a small amount of computing power. So it could be something like Citrix or VMware, or it could even be a web browser, right? So the functionality of the thin client is to provide the user that connectivity, that interface to the cloud. So they're able to connect to the application via the thin cloud, via the thin client. And they don't need to have a dedicated machine to do all of this, right? So that's what you got to understand about this. So and also the user doesn't need to worry about upgrading this software. So whichever software he's using, whichever application he's using, he doesn't have to worry about upgrading it. So whatever updates are being done will be done at the back end on the cloud, and that automatically becomes available for the users. So then, I promised you that I will try to make things easier to understand, and I said I'll provide you some analogies. Um, I think the way we deal with this is just look at well, you move to a new city, say Leeds, and you want a place to live. What do you do? So what do you do? So you have a few options. Do you buy a new house, or do you build a new house, or do you live in a hotel? So if you can understand the differences between these three, that pretty much justifies the need for cloud computing. That kind of gives you the differences between the different models of the cloud deployments. So we will go into these details in the next few slides. So yes, you could build a new house. Seems pointless. At least as a student, I don't think you will, if you moved to Leeds just for your university, it's pretty much pointless to build a house in Leeds. But the benefit is, leaving that aside, the benefit of that is you fully control everything you want. You design it the way you want, but it's all hard work. So you can design the interiors, you can design what kind of cladding goes in, how many windows you need, etc., etc. So, but it's hard work, right? Building a house from scratch is hard work. A step up from that would be to buying an empty house. The house is already there. You can customize parts of it, not all of it, parts of it, and maybe add your signature if you like, a stamp, your own stamp. So you can probably select the wallpapers and the paint and bring your own furniture. But what you can't change is the original architecture of the house. Well, you can change the original architecture of the house, but you need a planning permission, which is a lot of hassle. So let's assume that you can't change the original architecture of the house, right? So most people who move into an empty house prefer to keep it that way. And what they do is they just change the interiors, but they cannot do anything except that. And they cannot structurally change the outside of the house. So finally, the simplest thing, you don't want the hassle of building a house or moving into an existing house. So what can you do if you got the money for it, if you can afford it, you can stay in an apartment or a hotel. So you can just enjoy your life, put your feet up. There is nothing else for you to do except living in a house. And if you're lucky, you might also get a housekeeper, someone who will change the sheets, clean the floors, etc., etc. When you're not there, obviously. So that's a good life. So you can. So these are the three models. Well, when it comes to moving around, right, or moving in. So these are three models which are there. So let's try to put that into context with the three cloud computing models we discussed. So infrastructure as a service is similar to building a new house. So you're trying to see how it all corresponds to the cloud paradigm. So infrastructure service is similar to building a new house. You can rent some virtualized resources or infrastructure and build your own IT system from those resources. And of course, you can have full control over what you have built. You will need to identify what is it you need to build a fully fledged IT system. But you don't want to buy it yourself. So what do? You subscribe to them from the cloud and build whatever you need. Now with platform as a service, the second bullet point you see there, it's like buying an empty house. It's already there. You just buy it. So for the developer who has, when I say developer, the builder who has built the house for you, they have a standard set of specifications, and all you merely do is buy it from them. So this way you can develop your IT system with what the cloud provides you, but you don't have to worry about any lower level resource management. All happens behind the scenes and you simply don't care. That's how it should be. And the final thing you see there is software as a service. It is similar to living in a hotel where everything is provided for you. The bed is there, the wardrobe is there, the carpets are there, the furnishing is done. So this is the kind of cloud environment where there is software or applications which you can readily use without knowing how it is provisioned or what resources are being used. You don't have to worry about any of that. You don't have to worry about the technical details or how the application was achieved. You only pay for the application. That's all you do. So this diagram here shows what is exposed to the user depending on their level of subscription. So which software is provided depends, well, let me put it this way. So it's about merely, so depending on what they have subscribed to, they get access to different parts or different features of the cloud. So the customer, if you're just using a software service, you don't, the customer doesn't see much except the application, only the top level applications, but they don't have control over the network, servers, or operating systems, or the individual capabilities of the application. So none of this is visible to some of to the users who subscribe to software as a service. The only thing they can do with software as a service is possibly configure some aspects of the application, but that's it really. So this is the reason why software as a service is often referred to as on-demand software. It eliminates the need to install your own software because the applications can be easily accessed by virtualizing the applications over the cloud. So let's look at the next one there. So let's go a bit more deeper. So for example, what if the consumer gets access to various programming languages? What kind of a model is that? So let's say that they want to use APIs or the application programming interface, etc., etc. So in this kind of a structure, he still doesn't get access to the fundamental cloud architecture, which means that they won't be able to control the network, servers, or any underlying operations. So all they get is, so in the platform as a service, they get the platform. That's pretty much it. So you get the platform to develop your applications. Nothing beyond that. All right? So in platform as a service, the cloud providers distribute the computing platform. They distribute the computing platform, which includes the operating system, the programming language, and the execution environment. And of course, there are obviously the things like databases and web servers. So all of this forms like a package. It's a package deal. So you get a package. You get the package for the development of your software, but that's it, right? So there are platforms which are able to automatically scale computer and storage resources that match the demand of the application. Let's say that you build an application using platform as a service, you build a software using platform as a service, and then you want to scale that software. So what the cloud environment will do is, what it can do is, it can automatically scale the resources to match the demand of the application. So the bottom line of all this is, the cloud user doesn't normally have to manage or allocate the resource. So be it either SaaS or PaaS, they don't have to manage the resource. So the final thing there is the infrastructure as a service. where the capability provided to the consumer is an arrangement where the consumer has to figure out, he himself has to figure out what he needs, and he has to accordingly provision for storage, network, and other fundamental computing resources. So it's pretty much doing everything yourself, but on the cloud. So in infrastructure as a service, the user has maximum control. He gets the maximum control over the underlying resources. But yeah, having said that, he still doesn't have the full control, or actually he doesn't need the full control over the cloud infrastructure, right? He only has control over the operating systems, storage, the deployed applications, and to some extent some limited control of networking components like firewalls as well. Yeah, so I hope that's clear. Yeah, so when you do the lab sheets, it becomes a lot more clear as to the distinction between these three models. This slide probably gives you a better insight into what is available to the users. I mean, in terms of visibility, what is available to the users and what is being managed by the cloud itself. I think we are repeating ourselves here, but it's still good to go through this slide. This diagram is quite easy to understand to get some clarity into the differences between the various paradigms. The first column on the left, the leftmost column, talks about packaged software. So it's packaged software, which is the traditional approach where you provision everything. So it's where you buy everything. You have the application, you have the data, you have the runtime, blah 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 blah. So all of that comes as that's what you do in the traditional approach. You develop everything, you manage everything, and etc. Right? So that is the leftmost column you see there in packaged application. But of course, then we have the infrastructure as a service, and where you have some amount of control over what happens with your infrastructure. So you develop the applications and you manage the data, runtime, and the middleware and the OS. You have some control over that. And then you have platform as a service, which is where you only have the platform, maybe a compiler or a development platform like .NET or whatever, or Visual Studio. So you have applications and the data, right? And the vendor manages the rest of the things. So runtime, middleware, OS, virtualization, everything is managed by the vendor or the cloud provider. In software as a service, none of that. All you get is a software or application, say for example Office 365. Everything right from the application to all the way down to storage is managed by the vendor or the cloud provider. All right, so you got to be very clear about this. So you guys got to understand, as you go from left to right, so this is how it works. So as you go from left to right in the diagram, the cloud platform has more work to do. So in software as a service, the cloud platform pretty much does everything, right? On the leftmost thing, in packaged software, you do everything. In the rightmost thing, in software as a service, the cloud vendor manages everything. So that's what you got to understand. So as you move from left to right, the cloud provider has more work to do, has got more management tasks because they have to control a lot of the aspects within the entire architecture. So there are more models based on slightly blended approaches. So for lack of a better phrase, we say it as a blended approach. So there are more models based on blended approach. Well, there are some on-premises resources which can be combined, so you have on-premises resources which can be combined with the resource on a cloud data center. So you can combine private and public, or private infrastructure with the public cloud. That's possible. So, for example, resources could be co-located. When we say co-located, it can be split. across sites, across cloud infrastructures. So it can be co-located where applications, functions, runtime and containers, networking, etc. can be based on premises, based on your premises, but then it can also be linked to a data center which provides the backend. See how it works, right? So it is possible to combine your own cloud, your own infrastructure with the public cloud. So it's quite a blended approach. To quote some with this example, so we have the CaaS, the container as a service. Containers as a service. It's very interesting, and it's a slight variation of IaaS, infrastructure as a service. And I'm not sure how much of the detailed software engineering you guys have researched into, but these days the trend is towards using containers on the cloud to develop serverless architectures. So what is a serverless architecture? So you got to understand that. What's a serverless architecture? So the serverless architecture is where containers, or potential containers, are able to provide the functions of a server, similar to a server, but without the server itself. So, but before you understand what containers are, you need to know what a workload is. So a workload could be a task, right? People often think of a workload as a program or an application, but this is completely wrong. A workload is not an application. It is more than just a program. It comprises of the resources needed to run the task, including compute cycles, memory, storage, network connectivity, etc. So all the functions associated with these tasks are a part of the workload. So think about it. I didn't mention about serverless architecture. So think about it. What if all these resources are made available via virtualization at operating systems level? So that's what containers are really. They are lightweight processes which can be accessed from the cloud, and they might contain some of the resources the developer might need to reduce the software overheads. So there's a lot of resources online if you want to look more into containerless, or rather containerized, if that's a word, containerized development and CaaS. So it's very interesting how it's possible to develop applications without any server support. So using containers, the containers provide the support, and then you can develop applications based on that. And it's quite a similar concept is the FaaS, the function as a service. FaaS, or function as a service, is a means of facilitating a serverless architecture. It's another ways of facilitating a serverless architecture. We have just studied what a container is. I've told you what a container is. But if these containers can provide functions that manage server-side logic and can maintain state through the use of services, it can promote a serverless architecture. So to make things simple, FaaS, or function as a service, is a model where the cloud provider manages the allocation of resources through the functions of a container. Now guys, I just want to just say something here which is quite important. So for those in the audience who don't have much of a software engineering experience, so please do some research on what a container is in context of a cloud. What is a container? And what's a workload, and how are those two linked? So please go through that, and all of this will become a lot more clearer. So the way you got to approach this is it would make sense if you understood the function of traditional servers. Let's go back many years. Let's think about a traditional traditional client server architecture. How does that work? Why do you have servers? That's the question you got to ask. Why did you have servers? When I say server, the servers in the machine which provides the backend. Why do you need that? It is to provide the backend functionality. But think about this. In a nutshell, if containers, if there are smaller entities, provide these functions, it removes some of the need for servers. So developers are now focusing on building serverless microservices. So remember this word, right? It's a microservice. And stateless containers. So they're focusing, the developers are this new trend in software engineering. It's about developing applications based on serverless microservices and stateless containers. So the way it works is in terms of a cloud, we talked about cloud metering. So the pricing, what you pay as a developer is based on the actual amount of resources consumed by an application rather than pre-purchased units of capacity. So then, here are some examples of various models. In IaaS, we have the Elastic Cloud. In Platform as a Service, we have the AWS Beanstalk, etc. In Software as a Service, we have Salesforce, Office 365, Google Business, Oracle, SAP, etc., etc. So it all makes sense, doesn't it? When you have given you I've repeated the same example actually a few times of your Office 365, where you're working on the cloud, but you don't concern yourself with how its operations are handled internally. So it all falls in. This all perfectly falling into its place. With regard to container as a service, the main thing you see there is the Kubernetes. Now, I don't want to go too much into detail with Kubernetes because if we start talking about Kubernetes, it will take another 12 weeks to cover all of Kubernetes. But so let's not. I'm just going to explain the concept of Kubernetes. So, what is Kubernetes? It's a portable, open source platform to manage container-based workloads. In the previous slide, I told you what a container is, and I told you what a workload is. But what manages this container and the workloads, or a set of containers and the workload? What manages it? So Kubernetes was what does that? So Kubernetes was created to overcome the issues with physical server resourcing. Now, if you look at the history of Kubernetes, it was first developed at Google, and then it was donated, I suppose. It was donated to the Cloud Native Computing Foundation. So it's open source. It is used to deploy and scale container-based applications. So if you are writing a software or an application based on containers, or if you're on serverless architectures, then Kubernetes is what lets you manage those containers. So obviously, if you are developing a big application, you will have a large number of containers or a cluster of containers, I suppose, and Kubernetes helps you manage them. I'm trying to think of making this easier to understand. So so if you imagine this as a platter, you've got a platter in front of you, and you assemble within this platter, you assemble the components you need on this platter, and obviously you scale it depending on your requirements. So a platter, so you get it's like a buffet, right? It's a buffet. You walk into a restaurant, it's a buffet. You decide what you want for your development. You help yourself to whatever containers you need based on your workloads, and that's your platter, right? And you get charged for it. But then the more number of platters you have, it becomes a cluster, right? So it becomes a cluster. So these clusters need to be managed, and Kubernetes does that. It helps you manage the cluster. Now, another way of explaining things easier is the one very interesting thing came out of Red Hat. So the engineers at Red Hat described Kubernetes like an orchestra. So imagine you are arranging an orchestra. It's like a musical orchestra. You are the conductor, so you are in charge of the orchestra, and you can decide who plays the trumpet and how loud, for how long, and when. So Kubernetes is all about the orchestration of the container service. So that makes it very clear, I think. I think that makes it very clear. So Kubernetes is about the orchestration of the container service. It helps create cloud applications with speed and agility. When you deploy applications using Kubernetes, you manage the containers life cycles rather than the application. So that's the best way to do is to compare this with what we are already used to. So let's go back to the traditional way of doing software engineering. So what you manage in software engineering is you manage the application lifecycle. So when you do the project management, you manage the application lifecycle. But when you're using cloud-based deployments using Kubernetes, you manage containers lifecycles, not application lifecycles. So in simple terms, you develop your application using services provided by containers. And a set of containers become a cluster, and Kubernetes helps you manage those clusters. And if those of you are interested in Kubernetes, it's a big part of what we call as development operations, DevOps. So yeah, so if it's a big subject in itself. So there, I'll quickly go through what is function as a service. So we have Azure functions, AWS Lambda, Google Cloud Functions, etc., etc. Now again, function as a service promotes serverless architecture. Now we all know that writing software, I mean, you guys are professionals at level 6 and level 7, so you guys know by now that writing monolithic set of code is inefficient. No one writes a monolithic set of code. You don't just put together thousands of lines of code in one single sheet and compile it. That's not how the software engineering works, right? So monolithic set of code becomes inefficient and becomes difficult to manage. So it's a matter of good practice to break it down into microservices. I introduced you to the word microservices in the previous slide. So with microservices they're modular components. They're small components used to build an application, and that's why it's called a microservice. So each microservice does something. It does a micro function, I suppose, right? So what that means is when you write an application, you divide the application into well-defined chunks of small functions where it becomes easy to change the code and embed it back into the development cycle. So this is what function as a service means. So if you are able to create those micro functions, if you think that your application, your code will benefit from those micro functions could already be available within the cloud environment as function as a service. So then, this slide just talks about the deployment models. We have already kind of covered all of this, I suppose. So we have different categories of cloud, like public cloud, private cloud, community cloud, hybrid cloud, etc., etc. With regard to public cloud, we have the usual suspects. We have Amazon, Microsoft Azure, etc., etc. And we have the private cloud, which you are already used to. You're already working with it. It's the university's overt system, which is one of the good examples of a private cloud. So with community cloud, I think we touched upon this in one of the previous lectures. It's similar to grid computing, where we can create a community of infrastructure. So it's about it's about sharing the infrastructure, and it's a collaboration, right? And finally, we have the hybrid cloud, which is a blend of private and public cloud. So typically in a hybrid cloud, sensitive data is stored in the private cloud, and perhaps some of the data processing functions can be subscribed from the public cloud. So there are different permutations and combinations of this. So many organizations do choose private cloud where sometimes they might think it's worth investing in a private cloud rather than subscribe to a public cloud on a long-term basis. So it's like weighing up your options um, on whether you want to build a one-time private cloud or whether you want to subscribe to a public cloud on a long-term basis. So now then, let's talk about cloud economics. We have spoken about cloud economics before, although we didn't call it as cloud economics. We'll call it now. We'll call it as cloud economics. We have covered this in the last lecture when we discussed about the resource utilization and how businesses can either underutilize or overutilize resource. What you guys have to remember is that multi-tenancy drives values. I think you all know what multi-tenancy is. It's where a single instance of a software runs on a server and it can be shared by multiple clients. Now, as long as there's partition between the data of different organizations, this approach is very cost effective, and that's why businesses are open to this idea of cloud-based resources. So yeah, it reduces capital expenditure. So when we're talking about economics, so obviously we need to talk about the capital expenditure and also the maintenance cost. If you use cloud service providers, it takes care of all of that. There is not much initial capital expenditure, and there is not much ongoing maintenance cost. So yeah, it kind of, it's a no-brainer really. So in terms of cloud economics, it makes sense to use cloud-based resources in most cases. So but all of this is now related to the utilization. So if we're going, we have to go back to what we mentioned about the traditional approaches about having on-site data centers, and all the problem is again with utilization. So we will explain the utilization in the next slide. But what about the advantages? So we spoke about corporates, we spoke about big businesses or offices. But what about the advantages from the economics point of view? What about the advantages for individuals and small groups of users? It obviously reduces local computing power. And you have seen this for yourself when you accessed applications provided on our cloud. Some of these applications may not run effectively on your laptop probably, but you don't have to worry about it because the cloud provides that computational power needed for using your applications. And also it also reduces storage requirements. And yeah, all you need is just a web browser to access a service on the cloud. So you don't really have to concern about how powerful your machine is. No, that's not something you should worry about. As long as you can run a thin client on your laptop, you should be able to access the cloud and tap into the power provided by the cloud. Now that graph is very interesting. There are two graphs given there. So one is it's basically a comparison of traditional data center and a cloud provider like Amazon Web Services. So this slide accurately puts into perspective, I think it's very accurate, it accurately puts into perspective the dilemma faced when we use a traditional data center. And we have already covered this when we looked into the concepts of underutilization, overutilization. But I want you to observe the blue line and the red line. Let us first look at the chart on the left, which is with the traditional data center. Now what you can see here is as time goes by, organizations predict the planned capacity. They try to predict it. They try to make an estimate of the planned capacity, and they incrementally increase the computing power. So you can see from the graph that the initial capital starts off as at a manageable level. So for most organizations, they have an investment for IT resources, and it's usually manageable. It's affordable. But then the problem arises with the red line. So the red line shows the usage. It shows the usage, and things start to get out of hand. The IT guys can start panicking, and they can you can go either ways really. So what might happen is they can overestimate the resources, so they can provision more, but what they might have is a situation where all the resources are not used and it wastes a lot of resources. So that yellow line is just a yellow shady area which talks about waste is wasted resources. So then the organization might think, hang on, we are wasting a lot of resources. Maybe we can scale back on the resources. So they try to cut down on the resources. And then what happens? There is customer dissatisfaction because there are not enough resources. So like I said in the previous lecture, there is no winning really. There's no winning. The situation of a traditional data center, you'll try to play catch up, but you never really can, right? But then compare this to something like AWS, which is the graph on the right. See how resource provisioning matches their actual usage. It's pretty straightforward to understand really. So because you only subscribe to the things you need in a cloud, you are not actually wasting any resources. At the same time, you are ensuring that you have enough resources to cope with your demand. So what we can conclude is that this is an optimal solution. I mean, in most cases, and most of the business cases, using a cloud provider for computing for your IT requirements is a sensible approach. This slide talks about the cloud computing benefits and looks at the pros and cons of on-premises deployment and cloud-based deployment. The pros of the on-premises deployment, let's be honest, I mean, there are some advantages to on-site deployment. The benefits being that you get complete physical access to the resources because it belongs to your organization, it belongs to you, so you have clear ownership, you have physical access. So it's just a matter of talking to your IT guys and telling them what you need, and you have a lot of control over that. So that is clear ownership. But the cons, the cons are, we have said numerous times before, is a capital expenditure. The capital expenditure, and look at the ongoing costs. It's the fixes, patches, upgrades, performance tuning, rewriting customizations, integrations, etc., etc. There's always an ongoing cost with on-site deployments. So there are all sorts of upgrades to do as well: network upgrades, hardware upgrades, databases, etc., etc. And of course, though, let's not forget about software licenses. You have to spend for that as well. So it is a pretty expensive affair. And as we have concluded in the previous few slides, you can never really keep up with your ever increasing requirements for computing power. It becomes very difficult. However, with cloud computing, your expenses are only the subscription to the services. So you pay an annual subscription or a monthly subscription, and that's pretty much it really. Plus, you might also have some expenses related to implementation and some training, but that's pretty much it really, right? So yeah, you got to weigh your options. Well, this is simple as that. There's nothing much for me to say really on that one. So yeah, IaaS helps you host your own services from the ground up, and you have control over the underlying infrastructure. With platform as a service, you build applications and have no control over the infrastructure. And with software as a service, you get access to the software. That's pretty much it. That's what we have seen in the last hour or so, or 45 minutes or so. So yeah. So here are some examples of the three cloud computing paradigms. I will let you go through that yourself. Otherwise, it's just me reading the bullet points. So yeah, I'll just let you go through this. So it goes through these examples of various cloud computing models. So that concludes this lecture. The next lecture will be on service-oriented architectures and web services on the cloud. So yeah, thanks.